welcome to all. Our engineering mechanics class number 74. We are in part 2, lecture 33 of part 2. We are in support reactions. In part 2, first we considered equilibrium, that all will come now. Then different types of loads, the most critical part of structural engineering. And now from past 1 or 2 classes, we are in support reactions. Class. See, I told whenever I dictate something, you should write. In engineering mechanics, we consider only statically determinate structures. That's all. Not me. Everybody in the world, when they consider engineering mechanics, they consider only statically determinate structures. Now, most of the people who have passed BE, if they are not knowing, at least they heard of it. Statically indeterminate and statically determinate. But briefly, see, statically determinate and statically indeterminate structures, class, briefly I will explain. Why briefly? Because this is not the time to explain all those things. This will be later, much more explanation will be there. Maybe I may talk or explain for more than 3 hours about determinate and indeterminate. When the time comes, first time it will come when you go to SFD BMD in strength of materials. Then it will fully come, means everything to be covered when I start structural analysis. Therefore, make a note, right now, engineering mechanics only statically determinate, not only me, everybody in the world. Okay. Now, still briefly, structures which can be analyzed by using basic conditions of static equilibrium alone. Suppose you can analyze a structure by using only basic conditions of static equilibrium, it is called statically determinate structure. Whereas structures which cannot be analyzed by using basic conditions of static equilibrium alone are called statically indeterminate structure. This will come when you go to structural analysis. Now, this does not mean that statically indeterminate structure cannot be analyzed. It can be analyzed by some standard method. I will tell briefly one mathematical example today. See, consider here. 2x plus 3y is 20, minus 6x plus 4y is minus 40. Now you should write here what I dictate. There are, see here, 2 unknowns are there. 2 unknowns. Which one? X and y. And there are 2 equations. 2 equations, 1 and 2. 1 and 2. Yes, we can solve. This 1 and 2 is like basic conditions of static equilibrium. So, 2 unknowns, 2 equations you can solve. This is statically determinate. You can analyze by using only basic conditions of static equilibrium. Now, one more example. One more. See, next example. Imagine 8x, you see the, why should I read it? These are the 2 equations right here. Here, 3 unknowns are there. 3 unknowns are there. Which one? X, Y and Z. But only 2 equations. 2 equations, 1 and 2. Oh, this you cannot solve. When 3 unknowns are there, we require 3 equations. Only 2 equations. Right here, there is a shortage of 1 equation. Shortage of 1 equation. This will be later called statically indeterminate to first degree later. Or 3 unknowns are there, only 2 conditions are there. You cannot solve this one by using only these 2 equations. You need 1 more equation. It is not there. So, if it is statically indeterminate, does not mean that you can't analyze. It has to be first reduced to statically determinate state. That is, those excess unknowns should be calculated by some standard method. I can tell you, slope deflection method, moment distribution method, Carney's method, consistent deformation method, strain energy method, column energy method, matrix sum methods are there. So many methods are there. Now, do one thing. Make a note. By chance, without disturbing these two, somebody will tell z equal to 30. Oh, now you can tell. That is, indeterminate structure analysis will tell you z equal to 30. Now, z is not unknown. It is known. It is known. Now what happens? Two unknowns are there. See, x and y, two unknowns. Two equations are there. Equation 1 and 2. You can solve. That's all sufficient for engineering mechanics. I told much more will be there, but some examples I'll give briefly here. Now, one doubt. I told basic conditions of static equilibrium. This term, I remember, you make a note. It is so thoroughly explained earlier. First of all, I should not tell anything, but still, because you are starting support reaction, very important, I will briefly write the concept here. Okay, now come to basic conditions of static equilibrium for a coplanar force system, or you can write coplanar structure, technically called coplanar force system. Okay, now this already known for you. Sigma fx0, sigma fy0, sigma m0. Those who want, write. But remember, xx and yy are mutually perpendicular to each other. Now, those who want, write once again. Algebraic sum of components in x direction for the considering the entire force system equal to 0. Algebraic sum of components in y direction considering the entire force system is 0. Algebraic sum of moment of the entire force system about any point in the plane, not required, coplanar, any point equal to 0, you write. This is told many times earlier. Remember, I told you. But remember, 99% cases, you write here, xx will be horizontal, yy will be vertical. But rarely you get they are inclined. In friction it will come. Okay, leave it now. Now onwards, you make a note, class. Actually, we are entering structural engineering now. The moment I considered types of loads and now support reactions, we are entering structural engineering field. Entire structural engineering and entire strength of materials. Only later in the friction chapter, I will once again come back here. Okay, I will tell at that time. Only for friction, you go back to fxy, sigma fx, sigma fy, sigma m. But entire structural engineering, later for SFD, BMD, or entire full structural engineering, we don't consider sigma fx0, sigma fy, actually this you consider, sigma m equal to 0. Okay. You don't consider, you can write, so many people are doing it, but I prefer to use the word sigma fx replaced by sigma h, sigma fy by sigma v, sigma m is sigma m only, or entire structure engineering now onwards. I will not accept in the case of friction. I will not write sigma fx0, sigma fy0, sigma m0. I will write sigma h0, sigma v0 and sigma m0. I like it. It is more conventional and more clear. Those who want, write once again. This is as I told. Algebraic sum of the components in horizontal direction equal to 0. Of course, considering the entire force system. Algebraic sum of component in the vertical direction equal to 0. Algebraic sum of moment of the entire force system about any point equal to 0 is what we are considering from now. So remember now onwards, except in friction, we won't use sigma fx, sigma fy, sigma m. We will use sigma h, sigma v and sigma m. That's all. I will not repeatedly tell. See, when I do the first example, numerical or problem, when I write sigma h0, I will write explanation. Sigma h0, sigma v0, sigma m0. Second question onwards, I will tell it is your responsibility to write. Now, all these basic concepts in the notes I will write. And when I write the notes, not one question, because people who are more depending on me, at least some 5-6 questions, I will write statement here. Then I will write there. Now onwards, you yourself do it. Like see, in the notes for parallelogram forces, I wrote many times. Then I told, mechanically, now you write. Therefore, now remember this concept. Now I will come to next part, which is required for you, how to find support reactions. Now, very important, to find support reactions, consider equilibrium of given structure. I am discussing only from engineering mechanics point of view. Okay, with action and reaction. Remember, make a note. One note you have to make. I forgot to write here now. One note you have to write. I will dictate here. I will dictate. When we can entire structure or part of a structure or any member or part of a member or for that matter each and every point of a structure is in equilibrium. When you consider equilibrium, maybe for a member, okay, do it only for member. It is in equilibrium under the combined effect of action and reaction. See, I will tell a simple example. You should write. He used a pen, applied a load. We saw pen falling down. No equilibrium. Now, he spread his 2 fingers and placed the pen over that one. He applied a load. Oh, it is in equilibrium because this is action. The load externally acting. From the finger here or supports, see when you apply load this way, I will give reaction this way. This action with the reaction together, member is in equilibrium. Remember, much or much power much. Much power much. The explanation will be there later. I will talk at least 4 to 5 hours or explain 4 to 5 hours when the time comes. That is to gain complete structural knowledge. This is not the time to discuss all those things like supported member, supporting member, suppose to make a cut in the member, consider part of member, what to do, how is the action reaction, that all will come later. Right now not required for you. So, no, dictated. For equilibrium, consider both action and reaction on given beam. Okay, now 1 minute, sorry, leave it here. This statement you are right now. Okay, action is now. Right now for engineering mechanics, action means whatever forces or couples are acting on the member externally. See, externally. Reaction means forces or couple will come little later, acting on the structure from the support. See, action external, reaction from support. Now, one simple example I will give you. One hinged support, one roller support. See, you write there. Consider a beam AB where left end A is hinged or pinned, right end is placed on a horizontal roller, subjected to random loading. See, some load and couple. Okay. Now, for equilibrium, consider both action and reaction on the given beam. Right here. What is action? Right. That load given, that couple given, and that loading UDL given, these are all action. Now, what reaction you get on the member from support is reaction. Now, write statement. A is hinged support. Already told last time. Hinged support will give this. I told you last time already. I won't explain. There will be a vertical reaction, direction VA. It is a hinged support. There will be horizontal reaction HA. B is a roller, a reaction normal to the plane. Here it is purely vertical VB. Therefore, now when you consider equilibrium, right here, this is to be considered for equilibrium. Means see, this one are action. This and this are reaction. Action with reaction will keep the member in equilibrium. Now you apply basic conditions of static equilibrium for this structure, where you have to consider both action and reaction. Right now sufficient for you. Furthermore, not required. Too much explanation is not required now, because we are limiting only to engineering mechanics. Later I will discuss much more. Okay, now I will just give one more example. I will give you for determinate indeterminate now with the beam example. Now, few examples for statically determinate and indeterminate structures. Briefly, remember very briefly, because time will come later when this class will be of around 3-4 hours duration. So many questions are there for getting degree of indeterminacy to decide determinate indeterminate all in SFD BMD partially and completely in structure analysis. Right now briefly. Okay, right. Example 1. You should write statement. I will dictate. Consider a beam AB where A is hinged support or pinned support, B is placed on horizontal roller, subjected to some load system. See, some load system. I told you already, this one are action. Action. This one, and this one are reactions. Reactions. Okay, now consider equilibrium of AB with action and reaction. Right here, A, the action already over. B, hinged support, vertical reaction, horizontal reaction. B, roller support, only one reaction. Now, this sketch, considering the member with action and reaction, separately if you draw without showing support, is called free body diagram. Some people, they don't show support. What they do is, they remove the supports. They will write here, see. This way. This is called free body diagram. This also is free body diagram only, but I am showing supports. And I want to show support because free body diagram, I will explain it later when the time comes when you consider part of member. Right now, ignore it. Somebody may tell, he to explain support reaction, he is not explaining free body diagram. You tell them, he will explain when the time comes. Right now, not required. See here, number of unknown reactions, 3, HA, VA and VV, 3. Number of basic conditions of static equilibrium applicable. This applicable term I will explain little later. Will be explained. 1 minute, wait for some time, have patience. Will be explained little later. But remember, I always use the word Number of basic conditions of static equilibrium applicable 3. Which one? Sigma H, sigma V, sigma M. Number of unknown reaction equal number of equation given beam AB is statically determinate. Over. Second example. Consider a beam fixed at one end and free at the other end. See, right here. Consider a beam fixed at one end, free at the other end with the loading. Okay, now, this is also called cantilever. You can make a note, cantilever. Okay. Consider equilibrium of AB with action reaction. See now, this is the action, but now, see, support A is fixed. A. Therefore, I told you very clearly, yes. Now, after the recording was over, I found a small problem there. I was explaining something here, but it suddenly stopped there. Some problem was there. So anyway, I think I already explained up to here. Cantilever beam, see. I was telling the word I already told earlier. Fixed support will have vertical reaction, horizontal reaction and reacting moment. Why anti-clockwise? Don't bother. I know it is anti-clockwise. You just write, see, 3 reactions. These are the action, these are the reactions. Number of unknown reactions, 3. HA, VA, MA. Basic condition of equilibrium, applicable. I will explain the word applicable, don't worry. Sigma S, sigma V. Therefore, same thing. Again, number of unknowns, equal number of equations. Given beam AB is statically determinate. Okay, now, example 3. Right, consider a beam AB which is fixed at both ends. You write there, fixed at both ends. Actually, when I go to indeterminate, my first example is propped cantilever. But okay, leave it now, which is fixed at both ends. Right. Consider equilibrium of AB with action and reaction. See, this is the action, but now your B is fixed support. B. Therefore, at A, fixed support, vertical reaction, horizontal reaction, reacting moment. At B also, vertical reaction VB, horizontal reaction HB, and reacting moment, I know it is clockwise, MB. Now, number of unknown reactions equal to 6. HA, VA, MA, this is at A, and HB, VB, and MB at B. Oh, number of equations are still 3. So, number of unknown reaction is more than number of equation. Unknowns are more. You can't solve. Statically indeterminate. Indeterminate. Okay, write this much. Sufficient. Time being sufficient for. Now, you make a small note. Those who are interested, small note you write here. I will come to applicable. You remove this beam. See, now, don't see anything there. Now, make a note here. Write this sketch once again here. I will remove the sketch now. Now see, this is all I am removing now. Write this sketch there and then tell. By chance, somebody will come and tell you, your vertical reaction is 81.8 kilonewton, horizontal reaction is 16.48 kilonewton, MB is 30.48 kilonewton meter. You ask him, hey, how you told? That is not your problem. You ask him once again, have you used any equilibrium condition? No. So that means he went for analysis of statically indeterminate structure, some method, and he got the answer. Okay. Then number of unknowns which are earlier 6 is now only 3. See, only 3. Why 3? HA, VA and MA at A, that's all. Because HB, MB, VB are known. Conditions are 3. Now number of unknowns equal to 3. Now the beam AB If you get those answers, will become statically determinate. Therefore, remember, statically indeterminate structure has to be first reduced to statically determinate state, then you can find reaction. That's all I want to tell. Okay, now, most important, I will tell what is the term applicable is very important. See, now, explanation, I require explanation for that word, which word? Applicable, where? See, applicable, this one here, see. I wrote it everywhere. I always write it. This one, you can write here, applicable. Put a star mark. Put a star mark here. Star mark. Applicable by me. By me. For that, to better understand, what you do is, you consider a beam. Write a statement here. See, I will dictate now. Consider a beam AB simply supported at both A and B. You should write. This is simple support, A and B. Subjected to any vertical loading with the couple. Okay, no problem. You write what all I am dictating, you are right. Otherwise, you will not understand. Subjected to any vertical loading and with couple or without couple. But no horizontal load. No horizontal load or force. Okay. Now write here. One more sketch you write here. Now write one more sketch. Consider beam AB with, as I told, action and reaction. Actually, this pen is giving trouble. I should change that one. Put some ink required. Okay, I will try something. Okay, yeah, start. Beam AB, see here, right here. A is simple support which can give only vertical reaction. Already told for you. B also simple support which can offer only vertical reaction VB. Remember, no horizontal load, no horizontal reaction. That's all. Or, see here, simple. Place a beam like this. Apply load. Only vertical loading. Therefore, number of unknown reactions is 2. Which one? VA and, it is which one? VA and VB, to make more clear. That is VA and VB. Number of basic condition of equilibrium applicable is not 3. If it is 3, it is nonsense. See, if 2 unknown is there, a number of unknowns can be more or equal. Unknown lesser, equation more is unstable structure. It is only 2. Which one? Sigma V equal to 0 and sigma M equal to 0. See? All falling down today. I don't know why. Sigma V equal to 0. Vertical no displacement, no rotation. And remember, sigma H equal to 0 is not applicable. Not applicable. Not applicable. You write the reason here. There is no place here. 1 minute now. Not applicable. Space is not there. I will write reason here. Okay. Why not there? No horizontal load. No horizontal load. Neither. There is neither there is horizontal load nor there is horizontal reaction. Horizontal reaction. Or make a big note, as big as possible. If there is no horizontal force or load and also there is no horizontal reaction. Both should not be there. Then sigma h equal to 0 is not applicable, or then basic equilibrium will be only sigma v sigma h. Remember now, but be careful. Suppose a question given this way later with inclined roller, be careful. Even if you apply only vertical load, see, vertical reaction, horizontal reaction, inclined reaction. Here inclined load reaction is inclined. That has a component, so horizontal is there. So I told you very clearly, neither horizontal loads and also nor horizontal reaction. There should be no horizontal load and no horizontal reaction. If both are not there, sigma h 0 is not applicable. Only sigma v sigma m are applicable. That's why I wrote applicable. Now, for that matter, see here. If a simply support beam is there, if you apply vertical load and couple, it will be stable. If you apply horizontal, see, if the hinge is there, it can take horizontal reaction. If you place both on simple support, a beam, like a beam resting on wall, if a horizontal load comes, see here what happens. It will get displaced. It is not in equilibrium. Okay, sufficient. Now, this is all explanation for finding reaction, all basic concept covered now. Now I am winding up the class. Next class onwards, I'll be in different mood because there will be non-stop problems. Non-stop problems. Maybe not around, up to around 100 problems I may solve. Because structural engineering, when you go to SFD, BMD, and also later in structural analysis, those who study from me should laugh if someone will tell reaction is a problem. You should tell reaction problem. No, it is easy. They may tell no complication. No. Then you tell them. If somebody tells I have difficulty for understanding reaction calculation, you can tell them. You tell my channel name and tell them go and study from there. But one thing you have to tell them, study everything, not randomly. You study from him everything. You can tell him you will become equal to me. Me means not me, you. Therefore, remember, very powerful classes are coming from next classes. I will go in a systematic order and cover complete support reaction for structural engineering. Thank you.